This is video 4.6.2, and the goal of this video is to summarize how to graph cosecant and secant functions. So as we talked about in class, these are very related to their fellow reciprocal function. So let's talk about some basics about the cosecant curve. First of all, the period. Again, cosecant is related to sine, so the period is going to be similar. It's going to have a period of 2 pi. So we have to make sure we graph a full period in order to see the full graph and what would happen over time. Now domain, reminder of domain. Domain is the x values. So the question is, what can x equal? Well, x cannot equal any multiple of pi. So notice that the asymptotes are at pi, 2 pi, negative pi, and negative 2 pi. So they occur at multiples of pi. Now where n is an integer, so n is 1, n is 2, 2 pi, 10 pi, there would be another asymptote. So they really occur halfway into the period, at the end of the period, and the beginning of the period. That's kind of what we want to remember. Beginning, middle, and end of the period, of one full period. What's the range then? Well, notice the range for cosecant is that y is either greater than or equal to 1 or less than or equal to negative 1. That red region I shaded in there is cosecant will never be anything in that red region. Okay, so it has to be bigger than 1 or smaller than negative 1. So with that, the asymptotes that occur are whenever n is an integer again, where x equals n times pi. So again, it could be at 10 pi or negative 10 pi or any multiple of pi where the n is an integer. So that's an important piece. We just really want to remember that they occur every full cycle later. Every pi, you're going to have another asymptote. And we'll talk about how to graph the transformations now of these functions. So let's talk about this first example. It's a good idea to make sure you get this example down so that you can use it when you need to, when trying to graph these functions. So before we graph it, we graph the corresponding reciprocal function. In this case, it's sine. Notice that I rewrote this in standard form so you can see that the inside has been factored, because that's going to help me graph it a little bit more swiftly. So I did that while I worked, and I'm graphing sine. Okay, so let's see, to graph sine, this is a good review of that. If you already know how to graph this sine function, pause the video, do it on your own, and then fast forward the video. But I'm going to walk through it again just to get more people to hear it and make sense of graphing sine. So first of all, I know that the starting point is always at h comma k. So that one is easy to me, because h is pi over 2 and k is negative 1. So I graph that first point. Now I'm going to find the period to find my next point. The period is always 2 pi divided by b, and b is 2 in this case. So I'm going to get a period of pi. So I go up distance of pi, and that's my next point. My end point, excuse me. Now the next excuse me. The next thing that's fairly easy is to find the midpoint for sine. It's at the same level, and it's halfway along the period. So that's also going to be down at negative 1, but it's going to be at pi, because that's halfway on the period. Now sine, to find the next 2 points, remember in between the first two we simply go up in amplitude, and since my amplitude is 2, I go up 2 and then down 2 between those next 2 points. So that's how I graph those next 2 points, up 2 and down 2 using the amplitude. So I did it all very visually because my graph was sort of already set up for me. So that's my one period of sine, but in order to graph cosecant, we should probably graph one more period of sine. So I'm going to extend this graph in both directions a little bit by just simply kind of copying and paste that curve that I already have. Now this is the sine graph. These are the key points for sine. Now we're going to draw in cosecant. Cosecant will have asymptotes and curves, and first of all, the asymptotes are between the maximum and minimum points. So if I go right in between the max and min, I would end up having the following asymptotes. Those are in the middle. The black points that I've not drawn the asymptotes through are the max and min, and I went right between them to draw in the asymptotes. Sometimes it may be easier to start with the curves and then find the asymptotes second. So the curves are simply at the max and min. And remember, it's a U shape and it goes away from the sine curve. So it's going to go up at the maximum and down at the minimum. So these are my curves for my cosecant graph. So this is my cosecant graph, the graph that's in red here with the asymptotes and the curves. So again, it may be helpful to do the curves first and then do the asymptotes. And you'll see me doing that in secant, so you can kind of get a picture of that. Now notice I did not draw in the sine wave. So the sine wave is the wave that goes in the middle. Some people draw that in with a dotted line because it's nice to see the sine wave and it's sometimes helpful, but you don't really need it because we're not graphing sine here. We're using this graph of sine to help us graph cosecant. So this is your graph and you are done if you graph the red function. So now let's talk about secant. Secant. Again, the period for secant is comparable to cosine. It is simply 2 pi. And normally graph from 0 to 2 pi, but we're always going to kind of double that right now, especially for these reciprocal functions. Now the domain, remember domain is asking about x. We have asymptotes, and so our asymptotes, if we look at our graph, are again at every multiple of pi over 2, because we have pi over 2, and then we go to 3 pi over 2, and so on. So one way we could describe that is x cannot equal pi over 2 times n, where n is an odd integer, because it occurs at 3, and then it would occur again at 5 pi over 2, or negative 1 pi over 2, or negative 3 pi over 2. So n can't be odd. If n is odd, then we would have an asymptote. Again, they're all pi apart, so there's other ways that we could describe this, but we want to remember that these asymptotes are all pi apart. They're really half of the period, but they're shifted compared to sine. Now the range is the same as what sine was, what cosecant was. It has to be bigger than 1 or less than or equal to negative 1. So one or the other, above 1 or below 1. Now asymptotes, very similar to domain, we're going to describe them as pi over 2 times n, where n is an odd integer again. Okay, so any odd multiple of pi over 2 and we will have an asymptote. And that's, of course, the parent function, but we're going to be graphing transformations. So let's look at an example of that in the two simple steps. Step 1, graph the corresponding reciprocal function. So I'm going to graph the function cosine of 3 pi over 2 times x plus 1. I'm sorry, 3 times that, of course. To graph cosine, let's find the period. It's going to take some dividing a fraction, 2 pi divided by 3 pi over 2. Again, just real quick, pause the video if you feel like you can graph this cosine function, and then watch the video again and see if you get it right. I will warn you, this graph is not set up properly. I do need to change the x-axis to make it more feasible to this problem. So you'll see me doing that in just a second. So the period is 2 pi divided by 3 pi over 2, because that's my b value. And to do that, I rewrite that as 2 pi times the reciprocal of the denominator, 2 over 3 pi. Simplifying, I cancel out the pi's, and I end up getting 4 over 3, because 2 times 2 is 4, and on the bottom is 3. So my period is 4 over 3. Notice it doesn't have pi in it. Again, why my axis is wrong. So a good idea would be to go by thirds. Now let's find this starting point before we finish setting up our graph. Our starting point is always h comma k plus a for cosine. Our h is 0. In fact, our k is 1, and then our a value is 3. So we're going to start up at 4. So 0, 4. So I'm on the axis, and I'm going to go up to 0, 4. Now, since my period is 4 over 3, a good idea would be to go by thirds on my axis instead of by pi over 2, which it went by. So I'm going to go by thirds on my axis, 1/3, 2/3, 3/3, 4/3, so that my final point can end where that red dot went, because that's a period away, because cosine will go a period away and also be at the maximum again. So I've got my beginning and my ending point. Now for my middle point. My middle point will always be the minimum unless I flip the graph. But the middle of this, in this case, is 2 over 3, because this is 2 over 3 right in the middle. And now I got to find my y value, but it's always the k value minus the a value. In this case, it's going to be down at -2, because 1 minus 3 is -2. And I'm going to have my point down at -2. Now, the next points. The next points happen to always be at the k value. So the k value, what I want you to notice, remember me talking about, hold on, sorry. The k value is always going to be your midline. And so if I sketch in this k value of 1, so we see a k value of 1, and when I sketch in this midline at 1 for my y value, that's the midline of this wave. And then I find the two values in the middle, and that's what I marked off in black here. These are the two values in the middle of the max and the min that I'd already graphed, these guys. So I'm going to graph, the points will be on the midline because they are in the middle of this wave. So graphing those, I'm going to end up with 2 more points on the midline, okay, for the middle, because they're literally in the middle of the max and the min, those last 2 points. So that's just a reminder that K is always your midline for sine and cosine. So now I've got my 5 key points. I am going to copy and paste these 5 key points to the left. And in order to do that, I have to set up my axes properly again. And then I'm just going to repeat that same period to the left. So I have all my points for cosine. Now I need to graph my secant function. So using the same idea as cosecant. So I'm again not going to really sketch in cosine. I'm going to use the same idea as cosecant. I'm going to draw curves at the max and min and asymptotes in the middle. So curves at the max and the min and asymptotes at the middle. And this is my graph of cosecant. Of secant, excuse me. Okay, so same steps. Again, you could sketch in your cosine function. This guy here, I'll draw it in for you. You could sketch this in with some dotted lines or sketch it in and then erase it at the end, but you don't have to. Your main goal is to find those key points and use them to graph the reciprocal function. Now here's your checkpoint. Oh wait, we're going to do one more secant because this is a common mistake on the quiz, so pay close attention here. This was a common mistake on the quiz when we have x divided by 2 inside of the trig function. So we're going to first start with graphing the cosine function. But before we do, I want you to understand that b is 1/2 because dividing by 2 is the same as multiplying by 1/2. So I needed to find the b value, something times x equals x over 2, and it's 1/2. So b is 1/2 in this case. So when I graph my cosine function, I'm going to use a b value of 1/2. Now let's take a look at what that will mean for my graph. First of all, my amplitude is 3. Yes, it's -3 is my a value, so remember that means my cosine is going to get flipped upside down. My period, though, is 2 pi divided by 1/2, which is equal to 4 pi. Again, dividing by 1/2 is the same as multiplying by 2. It's the reciprocal of 1/2. So I get 4 pi for my period. Notice there is no shift. There's no h and k value. They're both 0. So I'm going to start on the x-axis. My graph will not be shifted up or down. It will be centered on the axis. So it will be a no shift graph. Okay, so it's going to be very balanced on that x-axis. And start on the y. So my starting point, we always remember, is h comma k plus a. So remember my k was 0, my a was -3. So I'm going to start down at -3. Remember, this will be a flipped graph, so it's going to be an upside down U, and I can sketch that for you here. It's going to be a little upside down U like that because of the flip with -3. So my period is 4 pi, so I'm going to go 4 pi away, and then I'll graph the midpoint. It's going to be up 3 from the middle. So the midline, remember, is at k, and in this case my k value is 0, so this is my midline of my sine function, and so I'm going to have my last 2 points on my midline, and they're going to be at pi and 3 pi right in between the max and min. There's one period of cosine. Now I'm going to copy and paste that to the right and to the left in order to have a good picture of secant. So now my secant graph, remember the maxes and mins will be your arcs. So I'm going to draw curves at the maxes and mins, and I'm going to draw asymptotes in between them. And so this is actually 3 periods of the secant function. So that is what you should get for this one. So be careful with b values when we're dividing by things, because dividing by 2 is the same as timesing by half. I wanted to show that example because of the quiz. Take a look at your free response and your multiple choice question. The graph here in blue is either a sine or a cosine function. See if you can figure out what the rule is, and then convert that cosecant, or maybe it's secant, for the following graph. The next question is asking where the asymptotes will be for the function. Remember, the asymptotes depend on the x values, so see if you can draw a sketch of this function to help you figure that out. But try and find the asymptotes for y equals 2 secant of 4x minus 100. So bring your questions into class, and we'll talk about them and try to make sense of them together. But good luck, and thanks for watching.